What is up, guys? Welcome back to a new video. Today we're going to be looking at the introduction to sequences. So yeah, let's go ahead and proceed. So a sequence in essence, right? It's checking the index of every single value and having a different value to it in a certain pattern. What that means is, for example, we have here different indexes, right? What happens if I take 2i, right? What are we gonna get from that? Well, if we do 2i for 1, we're gonna get 2. If we do 2i, by this I mean 2 to the 1, and then we're gonna have 2 to the 2, so that's gonna be basically this. 2 times 3, that's gonna be basically this. 2 and 4, that's gonna be basically that. And 2 and 5 is basically gonna be this. Now, we have two types of sequences. We have geometrical, right? Right here. We have geometrical and arithmetic. Arithmetic, right? What do these entail? What do these mean? Well, geometrical basically means if we take a look at our example here, this little guy over here, right? And we take a look at this series, sequence. We can see that every time we go to the next term, right? We just sum up plus 2 simply. So plus 2, plus 2, plus 2, plus 2. So in a sense, this is what arithmetic is. Arithmetic is anything that has plus added to it. A geometrical one will be an example. For example, 1, and then 3, and then 9, and I don't know, 27, and so on and so forth. 27 by 3, I don't remember what that is. I'm taking out the calculator. 27 by 3, because my brain does not work right now. 81, right? This would be a geometrical sequence because it multiplies every term by 3, as you can see. So this is a geometrical sequence. So we can simply say that geometrical is when we use times. So up until now, we've understood what geometrical arithmetic sequences are. Now, how can we actually do the representation of this? So for example, when it comes to geometric and arithmetic, we can have two different ways of having these representations. We can have them in two formulas, right? So we can represent these two in two formulas. We can have them in the, what was it called? It was basically the formulas. It was explicit, right? It can be the explicit and recursive. I'm going to be explaining to you what each of these are. So yeah, let's proceed with that. So coming back to our example, now that we have that I wrote it right down, we have this this sequence that we want to find the explicit formula for. And so the first step we're going to have is first identify what type of sequence we have and what kind of pattern we have between our values. So for example, in here to here, you can simply see that's plus 3, right? And then from 5 to 8, once more, once more, and once more. As you can see, we have a plus 3. This means we have an arithmetic sequence. Arithmetic sequence, right? So yeah, now how can we actually solve to find this? Well, to simply do this, we only have to focus on four things. So let's write them down. Write them down in little dots here. We want to write them down here. And the things that we want to find is a of n, which is going to be our nth term. We're going to find a1, which is going to be our first term. We're going to find n. the term number we want to find. And D, which is a common difference. Common difference. Now, if we come back to an example here and we copy this, let's just copy this real quick, and we take a look at the values we need to find, we can simply say, right, the an is basically going to be the nth term still, so it's going to be an. And here, the first term we have is 2, so we're going to write here 2. N is going to be still n. That's just something that doesn't really apply here. And then D is going to be the common difference. The common difference is 3, right? So now that we have this, we can put it in our formula here, which is going to be an, right, is equal to a1 plus n minus 1 times D, right? So in this case, we're going to write in, that's going to be basically our formula. Now, how can we actually try this out? Well, we know that we have all the sequences, right? We have 1, 2, 3, 4, 5. This pink colored numbers are basically our indexes. So that is, if we want to find a n of 5, we simply do a of 5 is going to be equal to a of 1 plus 5 minus 1 times 3, which is our difference. In this case, we're going to have a1. Well, a1 is simply going to be 2, that I forgot to write in. And then that's going to be 4, right, plus 3. a5 is 2 plus 12, that's equal to 14. And as you guys can see, that is actually true. So that's how you find the explicit formula for an arithmetic sequence. Next, we're going to do one for geometric sequence. Okay, so coming back to our new example, we're gonna have this following sequence, right? And this following sequence is simply a geometric sequence. Why? Because we can simply take times 3 times 3 times 3 and times 3. So in the case, this is what we have. Now, really similar to our original arithmetic sequence, we can simply find the following. We have to find the following information to input into our formula, which I will supply later. But the first thing we want to find is nth term, which is going to be still a to the n. The first term is going to be 2. The term number to find is, well, whatever, this doesn't really matter in this case. And common ratio in this case is going to be 3. Why? Because the number we multiply it with. So, given this, we now are going to have the following formula for a geometric sequence. Remember, this is a geometric sequence. I totally forgot to write that down, so let me just right here. This is a geometric sequence because there's a multiplication involved. Geometric sequence, right? So a of n is going to be equal to a of 1 times r n minus 1. That's basically going to be our general formula, so to speak. It's important to note out that in some sequences, it is not a straightforward answer like this one over here, like this formula, but generally speaking, you're pretty much safe with this one. So let's go now with a of n, and we're going to write here 2 times 3. And in this case, we want to find right here, 1, 2, 3, 4, 5. We want to find the 5th value. So it's going to be basically 5 minus 1. And if we take my calculator here, let me just open it real quick. Where is my calculator actually? Just give me a second, you guys. There we go. No, I want to continue with this version. close this. So we have this basically, oops, what happened to my, oh, there we go. Sorry about that. So we have, we have the calculator here, right? And we're gonna write in 2 times 5/4. Oopsie. Oh no, sorry, I just made a mistake here. That was my mistake. It was 2. Why did I put 5? I just read the wrong number. 3/4. And that's gonna be 162. So 162. And as you guys can see, it is in fact this value. So this is gonna be basically it for this. In the next video, we're gonna be doing the recursive value, the recursive formula, which is just recursive. And we're gonna be looking at that later in the next video. Yeah, thanks for watching.